This is the Master Brewers Podcast, brought to you by the Master Brewers Association of the Americas, a volunteer organization dedicated to continually improving the products and processes of our membership since 1887.
Let's go!
Master Brewers brings you interviews with the industry's best and brightest in brewing science, technology, and operations.
Calm down, I'm moving too fast.
Support for this podcast and the following message brought to you by
Paul Muller Company has been manufacturing quality brewing equipment since 1964. Our innovative design and engineering will save you time, labor, and ingredients, sending money back to your bottom line. Learn more about our new mobile hop module at paulmuller.com.
Probably the biggest benefit is time and consistency. Whereas on the carbonation stones, how long can I really wait for this to dissolve and before I need to move the product into the next stage?
This week on the show, my friends Mimi Cartee and Todd Rausch from MG Newell Corporation join us to talk about technology that can be used for carbonation or nitrogenation of beer, production of deaerated water, and for oxygenating wort. All right, well, let's start off by describing dispersive carbonation. What does that mean?
Well, basically with carbonation, there are two ways you can carbonate. There's dispersive and non-dispersive. So the dispersive method is what's typically used with the carbonating stone technology. It's where you bubble in carbon dioxide in this case, or whatever the gas is. And then using a combination of time, temperature, and pressure, you can force the liquid, the gas to be absorbed into the liquid.
There's a very different way to achieve the same level of carbonation without dispersing. What are membrane contactors?
Membrane contactors are devices that allow a gas phase and a liquid phase to come into direct contact with each other. That's done with the purpose of getting transfer between those phases without dispersing, and I'm using air quotes here as I say dispersing, without dispersing one phase into the other. So you've got a porous hydrophobic fiber, if you will, that's hollow on the inside. You push the gas on the inside and the liquid is on the outside, and then the gas is able to absorb through or come through the fiber into the liquid.
What does a hollow fiber membrane look like? How big is it? What's it made out of?
It's a polymer. It's a hydrophobic polymer. The fiber itself is very, very tiny. Think of it about the size of a hair follicle, a piece of hair. So if you were to hold one, you really can't see that the inside of it is hollow. That's just how small it is.
Okay, so let's say we want to use a hollow fiber membrane to carbonate beer. How exactly does that work?
Yeah, so it's fairly a simple process. You're going to have the CO2 flowing through the center of the fibers through an inlet, and going in the opposite direction would be your beer product. And in this case, we're going to have it about 1 psi greater than the gas itself. So we're going to utilize Henry's law for the transfer of that CO2 into our beer that's going into our bright tank. And at the flow rates, depending on the size of the brewery, how quickly they're wanting this carbonation to happen. If we're looking at a relatively smaller brewery, they'll be flown anywhere between, for CO2, you can go anywhere between 15 and 20 gallons per minute on a smaller size membrane. And as that beer is flowing through, you got your CO2 in the opposite direction, and it's going to work through the pressure differential to carbonate the beer itself.
And that same hollow fiber membrane can be used to add gases to liquid or to remove gases from liquid, right?
That is correct.
All right, explain that.
Yeah, so the technology, the technology and the science behind it is literally the same. So, if you're wanting to strip oxygen, for example, out of your gas, and you're going to use a stripping gas, typically, actually in this case, in a stripping gas, you could use CO2. You could also use nitrogen, and there's some other variable stripping gases that you could use as well. And that would be what would be flowing through that center of the fiber itself. Product still flowing on the outside of those fibers, and again, you're still going to utilize a pressure differential between the two, and the CO2 then would actually be attracted through that membrane into the stripping gas, or the O2, excuse me, would be going through the fiber into the stripping gas and be taken away.
A brewery up in Virginia added one of the membranes into their incoming water line, and what they were doing was deoxygenating their incoming water. They were making high gravity beers and then using this membrane to deoxygenate the water for that purpose. And again, it's a great application. It's incoming water. They love it.
Coming up,
these hollow fiber membranes can handle, your very small 3-barrel systems all the way up to your, largest breweries built.
I'm John Bryce, and you're listening to the Master Brewers Podcast from the Master Brewers Association of the Americas. Here's what's coming up on the Master Brewers calendar. District New England meets in Pawtucket, Rhode Island, April 6th. District Texas meets in Shreveport the weekend of April 6th. The 3rd Annual District Southeast Crawfish Boil is April 7th. The Master Brewers Board of Governors meets April 12th. District Southern California meets at Three Weavers Brewing April 12th. District Carolinas meets at Holy City April 14th. The Master Brewers Brewery Packaging Course begins April 15th in Madison. District St. Louis meets April 19th at Four Hands Brewery, and the 57th District Caribbean Convention is April 19th through the 22nd in St. Lucia. View the full calendar of events at mbaa.com for more details or to find a district meeting near you. Now back to the show. All right, how do you clean and sanitize hollow fiber membranes?
To clean them, they you run your normal CIP process through them. You can run a caustic, then followed by an acid rinse. You can also do hot water rinses. So it's a fairly straightforward CIP process.
And there's one watch out when it comes to CIP with standard built or packaged cleaners. What's that?
Well, you don't want to use any kind of soaps or surfactants. The way the technology works is that the fiber is hydrophobic and you want it to stay hydrophobic. So if you use a soap or any sort of detergent, then that's going to decrease and could even eliminate the hydrophobicity of the fiber. So you want to stay away from any type of product like that.
Okay. And how about storing these things between use? What's the best practice there?
Yeah, really the best practice, if you're not going to use it for a few days or even in a longer extended period of time, you want to fully evacuate that membrane with all the liquid that's possible, and then you want to go ahead and cap it off and purge it either with CO2 or nitrogen and keep that under pressure. And then you can store it. Really, you can store it in for as long as necessary once that's back under pressure with either your nitrogen or CO2.
Where are most brewers using membrane contactors in their process? Are they setting up pump around loops on tanks, putting the unit in line on the way to the bright tank, or something else?
Yeah, really, it's kind of a preference for each brewery itself. So we've seen a lot of them that are either put in just before the filler, either on a portable or a permanent mounted system from the bright to the filler, especially if they're just making sure that they're right at that fine line of CO2 where they want, or if they are putting nitrogen in that just before the filler. The other is kind of in between the fermenter and the bright tank if they're trying to strip any kind of O2 that may be residual. And then I've also seen some of that coming from the wort cooler into the fermenter itself when they're actually adding O2 to go ahead and get that prepped for fermentation. So it's really it's very versatile units, and they can either be portable skid-mounted units or they can be permanently mounted into your inline process. So it offers a wide variety of of use throughout the system itself.
Do they require continuous flow, or can they handle processes that start and stop?
They run better if they're in a continuous flow process. Again, it's a matter of getting the pressure set, the 1 psi pressure differential, and once you get that set, you can let it run for days and days, really, and not have to keep readjusting your pressure. So ideally, you do want to put it somewhere in the process where you can let it run as long as possible.
There is a wide range of flows. So these hollow fiber membranes can handle your very small 3-barrel systems all the way up to your largest breweries built.
Right.
So they can handle from flows through these membranes from about 5 gallons all the way up to 1,000 gallons per minute. And then we can stack membranes, so you can even get even higher flows. It just flows through multiple membranes.
There's more and more unfiltered beer out there. Can you run unfiltered beer through a hollow fiber membrane?
You can. We don't recommend it. What happens with an unfiltered beer, the same thing that would happen with a carbonating stone, is it can clog the pores. So you end up having to do a lot of back flushing and a lot more cleaning than you would on a filtered beer. So it can be done. We would probably just recommend that you run it on a filtered beer.
How often do you need to replace the membrane, and is that as simple as just putting in a new cartridge into the housing?
Yes. The membranes, it depends on the number of hours that you run it, but a typical brewery, a membrane would last anywhere from 3 to 5 years. And it's as simple as pulling out a filter membrane and putting a new one in. It's a very simple process to change it.
What are the pros and cons of using a membrane contactor versus the other technologies commonly used for carbonation in breweries?
I think probably the biggest benefit is time. If you're using a carbonation stone, or if you're using, or even using the kick to keg version of either CO2 addition or nitrogen addition, you just get a much more consistent and a much more quick transition between that gas moving into your product. So really, it's time and consistency with the utilization of Henry's Law here with the membrane. You're going to get a very consistent transfer, whereas on the nitrogen stones or carbonation stones, you're really just kind of hoping that you get as much in there as you can, but you're really just relying on, okay, how long can I really wait for this to dissolve and before I need to move the product into the next stage.
That was Mimi Cartee and Todd Rausch here on the Master Brewers podcast. If you'd like to learn more about hollow fiber membranes, check out the poster Todd presented at the 2017 Master Brewers Conference in Atlanta. If you don't already have the conference proceedings, pick up your copy by clicking store from mbaa.com. 130 years ago, Master Brewers was built on the concept of brewers helping each other out so we could all make the best possible beer. That's still true to this day, and it's where a lot of the camaraderie in this industry originated. Master Brewers' award-winning Ask the Brewmasters is the best place to go for troubleshooting, where you'll find the industry's only discussion forum that's moderated for technical accuracy by a team of experts. See what everyone else is talking about at community.mbaa.com.
Maybe 2 things that you should have known, maybe 3 things